So that would be my final answer. X plus 1, x minus 3, x plus 2. So x is equal to negative 1. X would be equal to positive 3. X would be equal to negative 2. These are all factors. These are all factors of x cubed minus 7x minus 6. And we're going to talk about what factors means in a second. Let's do the more complicated question that I was talking about. This is actually a very complicated question. You're going to need a lot of room. Okay, so I have x plus 9 goes into, now when something is, the reason this question is going to differ than the last question, because we had a remainder of 0 in the last question. That means all our terms were factors. However, here we are going to generate a remainder. So I'm going to start off with multiplying x plus 9 times x squared. And when you do that, we get x cubed plus 9x squared. Subtract those two equations. That's going to give me 4x squared. We have to bring down the positive 39x. And so it makes sense to generate a 4x squared. I'm going to multiply by 4x. So that gives me 4x squared. 9 times 4 is positive 36x. When I subtract those two equations, I'm going to generate a 3x. I have to bring down the positive 46. And when I bring down my positive, so 46, I should generate a positive 3 up in my quotient. Positive 3 times x plus 9 is 3x plus 27, which gives me a remainder of 19. So if I want to write out my solution, x cubed plus 13x squared plus 39x plus 46 is going to be equal to x plus 9 times x squared plus 4x plus 3. Can anyone tell me how to break up my quotient? How can I break up x squared plus 4x plus 3? What does that factor to? Oh, and I forgot my remainder, plus 19. How do I break up? Yep.
X plus 3 times x plus 1.
Good. X plus 3 times x plus 1 plus 19. Everyone okay with that? Okay, so now let's move on to another theorem. The remainder theorem. So when a polynomial f of x is divided by x minus a, the remainder is f of a. Since the dividend is equal to the divisor times the quotient plus the remainder, f of x is going to be equal to x minus a times the quotient plus the remainder. The remainder theorem tells us that the remainder, without having to divide, if the remainder is equal to 0, then x minus k is a factor of the polynomial. So only if the remainder is equal to 0, x minus k is a factor of the polynomial. If you do have a remainder, then the terms are not factors, or the divisor is not a factor. Only if you have a remainder. Okay, does everyone have this copied down? Move on to some examples. Use the remainder theorem to determine the remainder when p of x is equal to 2x cubed plus x squared minus 3x minus 6 is divided by x plus 1. So we already know how to do long division. We're going to use the remainder theorem in for non-traditional type questions, and to just figure out, is x plus 1 a factor or not? Oh, actually, this is not a factor because it says to determine the remainder. So because there will be a remainder, x plus 1 is not a factor. But we can figure out what the remainder is going to be if you're just simply figuring out the remainder, we don't have to go through the whole long division process, and you'll see why. So I know that x plus 1 cannot be equal to 0, so x cannot be equal to -1. So that is my restriction. Now, step number 2 is going to be the plug in the restriction into the function. Plug. So the way we're going to do that is my function is 2x squared plus x squared minus 3x minus 6. So instead of x, I'm going to plug in -1. So I have 2 times -1 squared plus -1 squared again. Oh, sorry, that should be 2 to the power of x cubed. So 2 to the power of -1 cubed plus -1 squared minus 3 times -1 minus 6. That's going to give me -2 plus 1 plus 3 minus 6, which is equal to -4. So that means if 2 to the power of x cubed plus x squared minus 3x minus 6 is divided by x plus 1, the remainder will be -4. Otherwise, you will not earn the marks on the test. Okay. This would be the same sort of deal, except what you would be plugging in is 2x minus 3 cannot be equal to 0, so 2x cannot be equal to +3, x cannot be equal to +3 over 2, which is the same as x cannot be equal to 1.5. So if we plug that into the equation, we would be able to find the remainder. Same sort of deal. We don't have to do this example. Now the next one is important. When p of x is equal to the same function we've been dealing with, 2x cubed plus x squared minus 3x minus 6, slightly different, is divided by x plus k. The remainder is 5. Determine the values of x. Now this is a good test question. Squared plus 10x minus 3. So if that is divided by x plus k, the remainder is 5. So we're going to set this p of x equal to a remainder of +5. Now I know the restriction x plus k cannot be equal to 0. That means x cannot be equal to -k. X cannot be equal to -k. So I have 3 times -k squared plus 10 times -k minus 3 is equal to a remainder of 5.